Hello, and welcome to Advanced XLSForm Techniques. I'm James Tedrick with the Survey123 team, and will be joined by my colleagues Brett Stokes and Philip Wilson. Today, we are covering a variety of enhancements you can make to your Survey123 forms and workflows. We'll begin by learning how to create different editing workflows with Survey123 Connect. We'll then cover how you can create custom business logic using JavaScript functions. A new feature added over this past year is the ability to collect polygons and lines. Aside from interactive collection in the map, we'll explore other ways to construct these shapes. Finally, we'll take a look at images from a couple of perspectives. First, using them to create a visual single or multiple choice question, and then how we can add and extract information from the photos created using Survey123. Just to remind everyone, XLSForms is the specification used to create surveys in Survey123 Connect. The form is authored in an Excel workbook with set names for the worksheets and columns, and is then processed into a form usable by Survey123, both the field app and web app, through publishing with Survey123 Connect. Let's now look at editing workflows. In particular, we're going to look at two workflows: asset inspections and approval queues. These are common workflows that many organizations using Survey123 implement. Both of these require us to think of the entire workflow when structuring our data tables and fields. They also will make use of Survey123's capabilities to update existing features using the inbox, and they can make use of multiple forms working with the same feature service. Let's start with creating a survey using an existing feature service. Survey123 Connect actually makes this pretty easy. First, in Survey123 Connect, log into your ArcGIS organization, whether it's ArcGIS Online or ArcGIS Enterprise. Select the Create New button to start a new form, and then select the feature service option. Connect will then list the feature services you can access. Select the feature service and then create survey. Survey123 Connect will examine the feature service, automatically creating questions for each of the fields, single choice questions for fields with coded value domains, and repeat sections for related tables. It will also add information to the settings worksheet that links the form to the feature service, preventing a new feature service from being created. Once the XLSForm is created, you'll need to modify the labels to reflect the questions you want to ask, as well as add any additional smart form logic, such as determining when a question is read-only, a question is relevant, or apply automatic calculations or default values. You can also remove questions if they don't pertain to this form. If you want to edit existing features in a feature service with Survey123's field app, you'll need to enable the inbox via the form settings prior to publishing with Survey123 Connect. This will allow the app to query the feature service and load existing features. As part of this, you can also apply a query expression to restrict which records are loaded in the inbox. The query expression can make use of any fields inside the main table of the form, such as the last modified date or a status field. You can also bring in the currently logged in user's username by using the $ curly bracket username placeholder. When enabled, the inbox will appear on the form's home screen, along with the Collect, Sent, Outbox, and Drafts box. Clicking on the inbox will display the list of features that have been downloaded onto the device, along with the ability to refresh the list. You can then view the features in either a list or a map, and then select a feature and open the form. Let's now dive into our first workflow, asset inspection. There are a few different ways to structure the data for this type of workflow. One is to have the inspection information in the same table as your asset inventory. This makes it easy to see the inspection status, but is limited to storing only the most recent inspection information. When the user updates the inspection, the previous information is overwritten in the database. Another solution is to have two tables, one for the asset inventory and another for the asset's inspection information. These tables can either be implicitly or explicitly related to each other. An implicit relationship simply has a field with a common ID in both tables. Explicit relationships will have a relationship class defined in the geodatabase or the feature service, enabling ArcGIS tools to automatically display the related information. Survey123 uses GUID-based relationships, whether using the global ID field or another GUID field. If you have existing data that are related via a non-Survey123, another solution is to have two tables, one for the asset inventory and another for the inspection information. These tables can either be implicitly or explicitly related to each other. An implicit relationship simply has a field with a common ID in both tables. Explicit relationships will have a relationship class defined in the geodatabase or feature service, enabling ArcGIS tools to automatically display the related information. Survey123 uses a GUID-based relationship, whether using the global ID field or another GUID field. If you have existing data that are related via a non-GUID relationship, you can still edit data using Survey123, though you may need to use multiple applications or forms to complete a workflow. Just as there are multiple ways the tables can be created, there are multiple ways to design the form. By default, Survey123 Connect will create a form that includes both the asset and inspection tables together in one form. This allows the author to view or possibly update the asset inventory information, as well as view the inspection history in the form while conducting a new inspection. This will require an explicit GUID-based relationship, however. Another option is to have a form that only edits the inspection information. Because this form doesn't have a repeat section for the inspection, it can be much more flexible, not requiring the inbox or a GUID-based relationship. It will need to have some way to specify which asset this inspection is for, whether via text entry, a drop-down question, or having the value passed in through another application. When opened via another application, it is possible to copy additional data from the opening application into the form. To begin with, we have a feature service of water inspection stations in the state of Maryland. Clicking on one, you can see that we have the name of the station, the county, whether it's public or private access, and whether it has a water station advisory currently. That's our asset information. Related to it, we have a series of inspection records. So let's make use of this feature service as we create an editing form in Survey123 Connect. I'll go to New Survey, and again, select the feature service option. You can see the list of feature services that are in my organization. I'll find the feature service I want to use, give my form a name, and then create a survey. As I mentioned, Survey123 Connect is scanned the feature service, identified the fields present, and created questions for each of them here in this Excel file. You can see the main layer of my form here at the top with the location of the water station, name, type, and the advisory information. The inspection information, which is in a separate table, is located within this repeat section. The name of the repeat indicates which table this data will be written to. Going over to the settings worksheet, I can see a couple of settings have been added. The first is the submission URL. This, again, identifies the feature layer item in my case, ArcGIS Online, that this form will write to. The form ID indicates which table will be written to. You can see that my form is pretty basic. We do have choices made where there is a domain in the field, but aside from that, no real options with appearances or smart forms have been made. So let's begin to modify that. I'll first put the beginning information, the information about the inspection station and the water body here inside of a group. And then in that group, before the advisory information. I'm doing this because this information is not going to change from inspection to inspection. So we'll make this read-only and make it available for reference, but not necessarily show it. So we'll just make these read-only. And then I'm going to make the appearance of this group compact so that it's present, but doesn't show by default. And also I'll make the water body type a minimal appearance just so it appears as a drop-down and doesn't take up so much space. I'll create a second group for the advisory. And also just name and label that group, and then provide a couple of appearances again to make this a little bit nicer. So I prefer using the Likert for yes, no, not applicable questions. And then we've got start date and end date. We can set a calculation on the start date that if the advisory is yes, then apply the calculation of now. Otherwise, we can leave it blank. So if we save this, we'll see some of these changes take effect. As I mentioned, the actual inspection information is stored here in this repeat section. I'll just rename this to inspection. And again, we can apply some appearances, in particular, and calculations. In particular, the default time for the inspection should be now. And we have these fairly long choice lists that I'll make minimal just to remove it. And also for the purpose of this demo, I'm going to remove a few other questions just so that you can see the entire form on the screen. I also don't need the station number, so I'll just remove that from this form. That's an internal code number for the station that the user is not likely to need to know nor edit as we go through. So you can now see our form is ready to go. Because we want to edit the existing information, let's go over to the settings and enable the inbox. When we enable the inbox, you can see that we're presented with the ability to provide a query expression. In this case, I'm going to limit it to just one of the counties, Frederick County. You can also see that we have the option for the map to further filter our list as we scroll through in our device. Now that we've got the inbox set, we're ready to publish. One final thing is whether we want to be able to view existing records from our inspection. If we want to do that, we need to specify that in the form. We can do that in the bind Esri parameters field that you see here. This provides us a setting for the form that reflects custom information about this feature service. The first thing we'll do is say that we want to query the existing records. And by default, we will query all of those records. The second is whether we want to allow updates to those previous inspections or not. In this case, we don't, so I'll use false. This is the default value, but I wanted to show it on the form so that you could see it. One final save. And we're ready to publish. Now, if we go to our form, I can download the survey and access the inbox. By default, we're given a set of information about the label here. We can actually modify this by using the instance name setting in our settings worksheet. So if we go to settings, go to instance name, we can provide an XLSForm expression. In this case, I only want to show the water body name. Save that again. And republish. So I'll update this survey using the new feature coming in the next version of Survey123. And refresh my inbox. And now I see just the water body name. If I go to the map, I can see the water stations. And if I zoom to the same area, I can see those same stations. Let's go to this station, which currently has an advisory. Once selected, we can see the information. So this currently has an advisory. Looks like it's well finished, so we'll say it no longer has an advisory and clear out that information. I can see the previous inspections and create a new one. Provide the information in the form, and then submit. After submitting, you'll see that this station no longer appears in the inbox and that the data is updated in the web map. As I mentioned, I could go through and modify this form further. If I wanted to have this be an inspection-only form, I would remove these questions from the repeat, or from the parent layer, as well as the repeat section. I'm going to copy the name of the repeat for now. So this is now an inspection-only form, but we would still need to provide some method of identifying the station that it works with. For now, I'll just provide an integer question that lines up with the station number field. So that's how we can create a form using the existing feature service for editing. First, using both the asset and inspection tables, and then second, an inspection-only form. Now that we've looked at using the inbox to create inspection records, let's shift gears to a second workflow, being able to have one group submit data and another approve the submittal. This is especially useful with crowdsourced or other surveys that have many contributors. The submissions will then need to be reviewed for completeness, accuracy, and appropriateness. There will normally be at minimum 2 stages, but you can have as many stages as your business process need. This workflow can also be used when there are multiple stages to collection. For example, when a first group goes and collects the basic details, and then a follow-on group or follow-on groups come in and answer additional questions within their areas of expertise. When designing these workflows, it's easiest to break out each discrete task as its own form. That way, each task can be customized in the appearance of its questions. Some questions, like approval status, may be hidden or not present at one stage, and then shown and made editable at another stage. Other questions may be editable on the initial submission, and then need to be displayed in a read-only manner so that they can inform but not be altered later. Another helpful step is to have some workflow metadata or status fields within the feature class and form you create. This provides you the ability to automatically mark the form as it goes through the approval process, or make it possible to restrict which stages can be worked on, or which stages can work on a form based on its status. To get started with a multi-step workflow, it's best to map out all of the questions and data needed across the entire workflow. Not only is this a good practice in design in general, but you'll normally begin by creating a form or feature service that have all of the questions or fields, a full feature service. This will then be used by all of our forms later on. Once you have that full feature service, you can then create a form for each stage by removing the questions that are not applicable for a stage, as well as making other ones read-only or hidden to match the needs of that stage. The first form is normally an initial submittal, the stage at which a new record is created. If you include a status field as part of your metadata, it's best to have it present in the form but hidden so that it will initialize the workflow but is not alterable by the user. Each subsequent stage will then use the inbox to open up the form for review or editing. Using definition queries, you can restrict the inbox entries to only those at the current stage. Stages after the first can have the status fields shown for the reviewer to move the form to the next stage and provide other comments as part of the review. Stages are not restricted to just Survey123. Other applications like Web App Builder and Dashboard can make use of the same fields and stages by using feature layer views that have the definition expression applied to the view. Let's now create a multiple stage workflow. Here you see a sample multi-stage workflow. This is centered around pedestrian safety requests with a public submittal comment area and then a review by trusted staff to ensure that the comments are accurate and appropriate to be posted. The submittal has questions regarding the pedestrian safety issues, and the review has reviewer comments as well as date. And you can see we've also concluded the form's metadata or the form status as metadata as well. When you're creating this, you don't need to have it as a group or organize this by groups, but it is helpful. So with this form now published, I can go and create a new form for the submittal stage. I'll again select the feature services and select my multi-stage form feature service. Looking at my stage 1 form, it actually has all of the questions. And this is what normally happens when you read a feature service. We don't need the reviewer information in this stage, so we'll remove that. We also have the status field here as an editable field. We don't want that normally for submittal. We want that to be a hidden field to provide a value by default. Looking at my choices, I want it to be a new submittal. So we'll apply a default value of new. We'll also need to provide a label for the question, for the location. So we now have a basic data submittal form that I can publish. Let's move on to the second stage, the review. This will look very similar. Again, we access the same feature service. And again, it has the same questions. In this case, we'll make the questions that were asked in the submittal read-only. So they're there for the reviewer to examine, but not actually provide alter information. We now have the reviewer comments, which will make a multi-line text box. And we also have the form status. To help organize this, we'll actually insert the group to indicate that this is the submission. Now you can see these questions are read-only, and that the reviewer comments are separated from the submission. In order to review the already submitted records, we'll need to enable the inbox. And to make sure we get the ones that are new, we'll ask for those whose statuses are new. Now we can publish this and have that second stage, the review stage, also present. So that's the beginning of creating a multi-stage workflow. Each stage is a separate form, and we use the inbox to load records from previous stages into the current stage.
Using the pullData@JavaScript function in Survey123. The pullData function can already be used to perform many different functions, such as returning a value from an external CSV file, providing location information from a GeoPoint question, returning device property information, or extracting EXIF information from an image. The pullData function can be used in both the calculation and constraint columns in your XLSForm of your survey. The pullData function has now been extended to work with your own custom JavaScript functions. This is an advanced technique that can help you introduce logic beyond what is possible through the standard XLSForm syntax. You can decide what occurs in your JavaScript function and return the needed values from the function back into your survey questions. The syntax for pullData@JavaScript is similar to the other pullData functions already supported. For custom JavaScript functions to work, they must be stored in the extensions folder of your survey. You can have as many parameters as you need in your function, and you can include as many custom JavaScript files in your survey as required. It is important to note that the pullData@JavaScript function is a beta feature that is publicly available in the release builds of Survey123. However, it is not currently officially supported. A useful application for pull data at JavaScript is with repeats. Using a custom JavaScript function, you have the ability to pass all the values across all the repeat records in your survey into your JavaScript function. The pull data at JavaScript function supports two different styles of implementation for retrieving the values from a repeat. Firstly, this can be done via the repeat name. If a repeat name is passed in, the JavaScript function will receive the parameter as an array of rows for all the values in the repeat. Secondly, by specifically defining the question from within a repeat. If a question from within a repeat is passed in, the JavaScript function will receive an array of values from the specified question. When using JavaScript functions to access web services and secure ArcGIS services, some properties are not available through the standard XLSForm syntax. For this reason, we have extended the collection of properties you can obtain using the property function inside your JavaScript function. This allows you to use important information to further enhance your JavaScript functions. Please keep in mind that there are a few known limitations when using JavaScript functions in Survey123. You cannot use Document Object Model, also known as DOM, nor can you use frameworks such as jQuery, Ember, and Angular. You cannot access local files on the device via custom JavaScript functions. You cannot make asynchronous calls, only synchronous calls are currently supported. The user must be signed in, and the user must originate from the same ArcGIS organization as the signed-in user. With that in mind, now let's take a look at how you can configure Survey123 Connect and a survey to use JavaScript functions and how this works in the Field app. Here in Survey123 Connect, we have two surveys which we'll take a look at that are currently using the pull data at JavaScript function. This is the Spatial Inheritance Survey and the VIN Lookup Survey. Let's take a look at the VIN Lookup Survey first. This survey has been configured to be able to take an input of a VIN number, which is a vehicle identification number, and it is a 17-digit code made up of numbers and characters that car manufacturers assign to an individual vehicle. Each part of the code represents a different information about the vehicle make, model, year, size, country, and many more important details that are relevant only to that car. This survey has been set up so that a user could enter just the VIN number and then find out other important information. We'll take a look at the XLSForm to see how this has been configured. Here you can see in Excel we have a GeoPoint question, which will be the incident location, and we have a text question to enter that VIN number. As it is an alphanumeric code, we need to ensure it is a text. We then have a calculate question, which will receive the entire JSON that is returned from the JavaScript function. Here you can see this in the calculation column where there is a pull data at JavaScript with myfunction.js, the decode VIN, and then the VIN which has been entered into this question here. Then we are using the following calculations for the next four questions are pull data at JSON, as this is a JSON that has now been returned. And this will now be able to pull out the results model year, the results make, the results model, and the results body class from the JavaScript function. So let's take a look at how this JavaScript function has been set up. If we open the files and we have a look in the survey folder, we can now see there's an extensions folder. This extensions folder contains the myfunction.js file. If we open this in Notepad, we can now see the function as it was written. It contains all the necessary parts and the URL to the service that is providing the formatting, and it is returning the response. So with this in mind, we'll have a look now at how this works in the Field app. In the Field app, we have downloaded this VIN Lookup Survey, and we can now open that as we would any normal survey. The JavaScript function has been downloaded in the extensions folder as part of the downloading the survey. So now we'll enter a VIN number into this survey and we'll see what happens. Here is a valid VIN number. The service is now going off and collecting that information, and it has returned that it's a 2001 Ford Ranger and a body type of pickup. So let's have a look at a different one. If we enter a different VIN number into this field, the JavaScript function will once again be run, and we'll now see that this is a 2013 Nissan Altima and it is a sedan or a saloon. And one more we could look up is if we were to look at this VIN number, we will see that it is a 2014 Chevrolet Impala, and which is also a sedan and saloon. So this is a very easy way you can use a JavaScript function to return information that you wouldn't otherwise have available and you would be requesting the user to type in. Now let's take a look at another survey that's using pull data at JavaScript functions. This spatial inheritance survey, similarly to the VIN number one I showed you, also is using a JavaScript function that's in the extensions folder. What this is doing is returning an address. So here we have set up our XLSForm to include some pull data at JavaScript to a function that is stored in the extensions folder. There are also some other pull data at JSON calculations, which are then pulling out the attributes for the place name, the zip code, and the state abbreviation. We also have the URL of the service that is being used, and we also have the full JavaScript function JSON being returned into this hidden field, so we can use this later. We've also configured a note to let you know that you're not in Palm Springs. So we'll take a look at that in the field app when we check out what location. Also now, to have a look at where this file is and what it contains, we can now have a look in the spatial inheritance extensions folder, open the JavaScript function, and here we can see how this JavaScript function has been written. As you can see, this one is a little bit more complex than the previous VIN one we have looked at. However, it contains all the required information to be able to run such a search. All right, now let's take a look at the field app so we can see how that has been set up. In the field app, we have downloaded the spatial inheritance survey. We will open the survey and check what details we get for the current location. Now that I have a valid location, here we can see my address. However, because we have an address here that is in Australia and not part of the US service that we were using, the other fields have not been filled in, and it is telling us we are not in Palm Springs. So now let's use the GeoSearch feature to do a search to bring up a valid address in Palm Springs. Here we select Palm Springs and we can move the pin to, say, one of these streets. Let's just put it here. When we accept this address, the JavaScript function will now be called again, and you will see it has been updated. We now have a place name of Palm Springs, a zip code, and a state all being returned from the JavaScript function. As you can see, this is an excellent way to be able to put this additional information into the survey that you wouldn't otherwise have available to the user. As pull data JavaScript functions are currently a beta feature, they are available via the early adopter community. Here we have a documentation article which includes all the information around pull data JavaScript functions. If you would like to check this out, please make sure you have subscribed to the Survey123 early adopter community and that you have a look through the project resources. You will find information around how you can get started using repeats, other properties that are available, some of the known limitations we've discussed. And we also have some examples such as a weather example, the VIN lookup which I've demonstrated, and some other files and exercises you can download here. Please make sure you check it out and let us know if you have any questions.
Hello, my name's Brett Stokes and I'll be presenting this next section titled Fun with Shapes. It's going to focus on building line or polygon geometry from repeated geopoints. Firstly, I'm going to give a bit of background on collecting lines and polygons in Survey123, and then I'm going to step through the process of setting up a survey that will automatically construct lines or polygons by collecting repeated geopoints. The 3.6 release of Survey123 introduced the much requested capability to capture lines and polygons from within your survey form. The Geotrace and Geoshape question types can be added to your XLSForm and published using Survey123 Connect. These question types are just the XLSForm terms for lines and polygons. Lines and polygons can be captured whilst using the field app or the web app, but at this stage the survey itself cannot be published through the Survey123 web designer, but only in Survey123 Connect. Support for adding line and polygon questions is coming in the 3.9 release of the web designer. As with all ArcGIS features, the parent survey can only contain one geometry type, that is a point line or polygon. However, other geometries can be used within your survey if they are contained within a repeat, so that they are stored as related features, or if they have their bind Esri field type value set to null, so they are not stored in the feature service at all. When creating your survey in Survey123 Connect, you can specify which capture method you'd like your field workers to use. The two options here are sketch and vertex, which I'll explain in more detail in just a moment. The capture method can be specified in the body Esri style column of the XLSForm using method equal sketch or method equal vertex syntax. If no capture method is specified in your XLSForm, the default will be to use sketch. If you're creating a survey based on an existing feature layer, then the method equal vertex will be automatically applied to your XLSForm, but this can of course be changed later if you wish. Collecting lines and polygons can be as simple as digitizing on the screen. Individual vertices can also be collected at known coordinates or locations using the search bar, or by using your GPS location, but this only applies to the field app. Location streaming, that's the ability to continuously collect locations while moving around a boundary, for example, will be included in a future release. Let's look at the capture methods. The sketch method is designed to be a single take. That is, the geometry capture is completed in one continuous pen stroke. If you're not happy with the result, you have the option to resketch or return to your previously captured geometry using the undo function. Regular geometries such as ellipses, rectangles, and triangles can be sketched using the Smart Shapes tool. The vertex method allows for more control over geometry capture. Individual vertices can be placed and edited using either screen taps, known locations through the search bar, using a GPS receiver, or the crosshair, which is in pan and zoom mode for increased precision. The entire geometry can be redrawn or individual vertices edited repeatedly until the user is happy with the result. You can populate Geotrace and Geoshape questions using calculations that incorporate the results of other questions. The most basic application of this will use a calculation expression that returns a string of coordinate pairs that describe the vertices that make up your line or polygon geometry. Each latitude-longitude coordinate pair needs to be provided in decimal degrees and separated with a semicolon. Perhaps a more useful application would be to use the sum function as a calculation expression for the Geotrace or Geoshape question. Summing geopoints within a repeat allows us to construct the line or polygon by adding the geopoints as vertices in the order that they are collected. The main advantage of this approach is that the GNSS metadata can be stored for each vertex, allowing the auditing of geometry capture accuracy. This methodology is currently limited to the field app only. Now that I've given a bit of a background, I'm going to step through a simple example which updates an existing power pole condition assessment survey to also capture the power line geometry. I've opened my existing survey in Survey123 Connect so that I can edit the XLSForm and review the changes as I'm making them. Currently, the pole location, along with the ID, pole type, and condition information are captured in the survey. Some GNSS location metadata is also captured when an external receiver is used in the field. Let's also capture the power line geometry in a Geotrace question and have it automatically populate as we capture each power pole. Firstly, let's add a Geotrace question to the survey. I'll just add this at the bottom. We'll set this question to read only as we don't want to digitize the line directly. Now we'll put our existing geopoint questions within a repeat. Finally, by setting our Geotrace calculation expression as the sum of our location fields, we can have the line automatically update each time a new geopoint is added. We can save our XLSForm and preview the survey in Connect. As you can see, the map preview has now been added for our new Geotrace question at the bottom here. So let's republish the survey and view it in the Field app. Okay, so I've downloaded the updated survey in the Field app, so let's try it out. I'll begin to add new power pole locations and complete the simple assessment for each location. Now as I move on and create more locations, we can begin to see that the line itself is being automatically populated. As I continue to do this, you can see that the Geotrace line automatically updates with each new vertex. You can see that here. If I were doing this in the field using an external GNSS receiver, you would also see the GNSS metadata populate for each vertex. As I'm just digitizing this on the screen in the office, the position source just shows as user. When I submit the survey, all the information is sent to the feature service, and this includes the power pole condition assessment, the GNSS metadata at each location, and the resultant power line geometry. More information on Geotrace and Geoshape question types can be found in the documentation and in a blog post at these links. This section is about using the image map appearance with select one and select multiple question types. I'll begin with some background information on using this appearance in Survey123 and then step through the process of creating a suitable SVG file and using it in your survey. The image map appearance gives you the ability to customize the UI of your survey without writing any code. A scalable vector graphic can be included in your survey and configured so that tapping on different parts of the image allows different selections to be made. SVGs can be downloaded from the web, created from scratch, or converted from existing raster images. They can also have raster images embedded within them. The image map appearance is the easiest way to add a big button type functionality to your survey form. Currently, the image map appearance is not supported in the web designer or web form. It is only available in Survey123 Connect and in the Field app. Here are the basic steps you'll need to follow to get started with the image map appearance. You'll need to obtain an SVG that you'd like to incorporate into your survey. I'll demonstrate how to create your own shortly. You need to add a select one or select multiple question to your XLSForm. You'll then need to create a choice list as per usual in the Choices tab of the XLSForm. You'll then need to add the image map appearance to the select one or select multiple question. You'll also need to add the SVG file name to the media image column of the XLSForm. Finally, you'll need to copy your SVG file to the survey's media folder. Here is some basic information on the SVG file format from a Survey123 perspective. SVGs are an XML-based vector image format that support interactivity and animation. The file contents can be viewed and edited in any text editor, but using a vector graphics package such as Adobe Illustrator or Inkscape will definitely be beneficial. SVGs can embed raster image formats as mentioned before, and I'll go into a bit more detail in my demonstration on this. Path elements with an ID value become the clickable part of your image in Survey123. And for this reason, the path ID values need to match the name value in your choice list, as you can see here on the slide. I'm going to talk you through the minimum requirements for your SVG file to be compatible with Survey123. The file must contain a path element that has an ID value. Non-path elements, such as rectangle, ellipse, circle, image, and text elements, will not be clickable. Likewise, path elements without an ID value won't be clickable either. You can't have any empty groups within your SVG file. Having empty groups, which is designated by the G tags with nothing inside them, will make all path elements become unclickable. You can only have one group per nest level. You can have as many nested levels as you like, but if you have more than one group at a particular level, including the parent level, all of the path elements become unclickable in Survey123. Your SVG height and width, otherwise known as the viewport, must be defined. While your image will likely display properly without defining a viewport, your clickable areas may become offset from the underlying image, so it's best practice to include it. Lastly, a view box, if specified in your SVG file, must match the viewport. You don't need to actually specify a viewbox parameter in your SVG element. However, if you do specify a viewbox that differs from your height and width values defined by the viewport, your clickable areas will be offset from the underlying image. Now I'm going to step through the process of creating your own SVG that takes advantage of the ability to embed raster images. This is one of the easiest ways to create an SVG file to use in Survey123. We'll use a JPEG image as a background and then draw shapes over the top that will become the clickable areas in Survey123. We can make these shapes invisible so as not to obscure the background image. Firstly, we need to open our vector graphics editor package. This includes Adobe Illustrator, Inkscape, and there's a bunch of online SVG editors like Vector, Boxy SVG, and Draw SVG. I'm using Inkscape in this example, which is a free open source package. The first thing we need to do is remove any layers. This will avoid Inkscape applying transform functions every time an object is moved around or resized, etc. Next, if we change the document properties to display in pixels, we also need to make sure that the scale factor here is set to 1. We're now ready to import the raster image. And we need to ensure that we're using the embed option here. Next, we can just resize the page to the current selection. And we're ready to start editing. We're now going to create a simple object over one of the circles, and we can use the ellipse tool for this. Once we've got it about right, we can always move the object later. But the first thing we need to do is convert this into a path object. You can do that by having the object selected and simply using the object to path tool. We can now see the path ID value, which gets a default of path 4533. And we can change this to fever. Now we can continue to copy and paste this circle over the remaining 4 images and update each one of the ID values accordingly. We'll just fine-tune the placement of the circle. And now just Control C and Control V to copy and paste. You can move these around and just update the ID value each time. Now that I've copied and pasted all of the path objects to cover our 5 clickable areas, I'll just go back and ensure that they're invisible so that they don't obscure the background image at all. We're now ready to save our modified SVG, and I'll save it directly into the media folder of our survey. I like to choose the plain SVG option as it includes less unnecessary information in SVG file. And I'll just rename this. We can now examine the contents of our SVG file in a text editor. As we scroll down, we can see the embedded raster image takes up the majority of this file. If we go right to the bottom, we'll see our 5 path objects with the relevant IDs that we'd set. Now we can open the XLSForm for our survey. And in this case, we're going to be replacing this select multiple question here for symptoms with our SVG file. To do that, we simply just need to add the image map appearance to the select multiple question. And then we need to add the file name over in the media image column. As you can see in the Choices tab, each of the options correspond to the path ID values that we'd previously assigned to each of the circle shapes. These become our clickable areas and return the values listed. If we save our XLSForm, we can now see that each of the 5 symptoms are now selectable. So to fill out the form, I can just add a dummy record here. And I can add my options. We can see here in the note that we can see the selected values. So creating your own SVG file to use in Survey123 with a raster as a background image and simple shapes over the top that become the selectable areas is as easy as that. More information on the image map appearance type can be found in the documentation at that link. A more in-depth look at SVGs in Survey123 can be found in this blog post, and a detailed sample survey that includes a variety of SVG elements can be accessed and modified through Survey123 Connect
using watermarks in Survey123. Here are some great examples of images that have been captured with Survey123 using the watermark feature. Watermark expressions are applied to an image question type in the bind Esri parameters column. The expression can include freestanding text, placeholders for coordinates, placeholders for date and time, and can make use of other formatting properties. Placeholder values are populated at the time of image capture. The notation differs from expression variables and are unique to watermarks. You can also use line breaks and separators to help format your expression. Please refer to the Survey123 documentation for a full list of supported watermark properties. You can also add a logo or image to your watermark by placing a PNG file in the media folder of your survey prior to publishing with Survey123 Connect. You can then reference the image file in your expression using the image equals, for example, esri.png. Image size associated with the logo can be set using the image size equals pixel size format. It is also possible to draw multiple watermarks on the same image. The watermark expression must include a space between the beginning of each watermark placement parameter. The example expression at the bottom of this slide combines many different parameters and properties to help display different parts of the watermark all in one image. A logo is displayed in the top left corner, and then the asset ID, latitude and longitude are in yellow in the bottom right-hand corner, and this was all done through the one watermark expression. Something to consider is that the watermark placeholder starts with an @ symbol and square brackets, which is unique to watermarks as I mentioned earlier, and is very different to the $ and curly bracket placeholder used for referencing values in a question. When a watermark expression includes a space, it must be wrapped in quotations. For example, watermark equals @time does not require quotations, whereas watermark equals latitude, longitude in decimal minutes seconds does require quotations, as there is a space in the middle of the expression. Formatting can be applied to placeholder values. For instance, @longitude DDM can be specified to display the longitude in degrees decimal minutes. While it is possible to reference values from previous questions in the watermark expression, it will require that the expression be constructed in the calculation column of a separate question, such as a note or calculate question before the image question type. The watermark expression can then reference the calculated value from the question using the $ curly bracket format. Now let's take a quick look at watermarks and how they work in both Connect and the Field app. Here in Connect, we have configured an image watermarks survey. Let's take a look at this survey. We have set up 4 different image questions. We also have other parts to this survey, not just date and time, but we have also included latitude and longitude, watermark placement, and multiple watermark and images. Here, let's have a look at the XLSForm. In the survey sheet, we can see we have added groups and we have added the image questions that we need. In the bind Esri parameters column, we will see the parameters that have been used. For a simple date watermark, we just use the simple equals date. For time, it is similar with a simple @time, date time. However, if we want to format, we will need to then include quotations and we'll need to include the formatting properties. Similarly, if we're looking at latitude and longitude, we can also do the same thing. We can set the size, and if we want to include both latitude and longitude, we will need to put a space and quotations. For other things such as the watermarks, to do with the placement, we can use the default placement, or we can specify where we want the watermark to be written. In this case, it will write top left watermark, and it will write the words top left, top center, top right, center placement, etc. If you want to use more than one watermark, you can use a space to separate the different watermark properties. Here we have a top left watermark and a center watermark on the same image. Or we can use, as I mentioned before, a logo such as the Esri logo on an image. And if you would like to use other properties and variables, we can also do this here. So we are here referencing this one called test note, and it will put the calculation from this test note into this watermark. So let's have a look at how that looks in the Survey123 Field app. I have downloaded the same image watermarks survey to my Survey123 Field app. Now let's take some images and see how the watermarks appear. Here we have the date and time on the first page that we had configured, so let's take a photo. When we capture the photo, the watermark will be added. If we open a preview of it, here we can see the date was written on the image. And if we were to look at the date time formatted example, here we can select it and see that when we take the photo, the date and time formatted in the format we want has been added. Now let's have a look at latitude and longitude. Here we'll just look at this example and we can see that the latitude and longitude of where the image is taken has now been written on. And for other examples of how you could put it in the top right corner, here the watermark has been added to the top right. And finally, let's have a look at what can happen when we put, say, such as a logo onto the photo. And we have added the Esri logo and a little bit of Esri text into the top left-hand corner. If you would like to find out more and use these examples, we have them available in Survey123 Connect. Now let's take a look at annotating images with Survey123. Using a standard image question in Survey123, you can draw or annotate over the image to provide additional information on your image in your survey. Survey123 supports 2 appearances for the image question. The draw appearance, the image question will display a draw button which loads the canvas on which you can sketch. Annotate, the image question will display an annotate button to open the canvas, however provides additional options to use an image from the camera, an existing image from the gallery, or a screenshot of a map. Survey123 includes a smart sketching tool to generate shapes and text annotations to sketch on the canvas in a very easy to use way. The canvas and resulting saved image will be the same size and dimensions as the device's screen resolution. It is also possible to use a default image as the canvas background. This is done by referencing an image in the default column that is stored in the media folder of the survey. For example, turtle.jpg can be referenced in the default column. Similarly, a calculation can also be used to dynamically set the default image using an expression in the calculation column. For example, concat_animal.png will use the text selection from a select one question called animal to select the related image from the media folder. Defaults and calculations can behave differently with image questions, using draw and annotate appearances. Using draw, the default image cannot be changed by the user. They must annotate or draw on top of this image. Using annotate, the user can change the image by capturing a new photo, selecting an image from the gallery, or inserting a screenshot of a map. Now let's take a look at how image annotation works in both Survey123 Connect and using it in the Field app. Here in Survey123 Connect, we have an image annotation survey. Let's have a look at how it's been designed. We've added a question for the draw appearance, the annotate appearance using a default background, and we also have a select one question here, which will control which image is used in the background of the canvas via a calculation. So let's open the XLSForm and take a look. Here in the XLSForm, we have the 4 image questions we saw in the preview. We also have a select one question. And as you can see, they have been set with the appearance of draw, and these 3 have annotate. For the default for this image question, we have set turtle.png, and for this one, the coyote PNG. And we are using a concat expression in the calculation column to allow us to choose a different select one animal in this question and set the image here. If we open the files, we can see there is a media folder, and here we have the 2 images. Now let's take a look at the Field app and take some photos so we can do some drawing and annotation. I have now downloaded the image annotation survey. Let's take a look. Here we have just the draw appearance. This means I can open and I will get a blank canvas. Here is the Smart Sketching tool. Here we can choose if we want to have text and at different sizes, arrows, lines, and we can also change the color. We can also undo and redo. This is the Smart Sketching turned on, and it will help turn shapes that we draw into regular shapes such as circles, squares, or triangles. So for instance here, I could try and draw a square, and as we'll see, it will turn it into a nice square and allow me to enter some text. We can also draw other shapes, and if it cannot turn it into something, it will leave it as it was, or if it is able to, if we change the Smart Sketching to use red, a smaller text and a smaller line, and we'll now draw a circle. Here it created a circle in the similar shape that I drew, and I can also now write some text. If we go back and look at the difference to the draw to the annotate appearance, here we'll see we have a camera icon, as this allows us to now capture a photo, select an image from your gallery, or use a map, as well as the Smart Sketching tools. So here we'll just set this a little larger again and make it blue, and we'll have a look at capturing an image. Now that we have captured an image, we can now draw on the image using the tools. Here I could draw a square around the house and then call it a house. We could also choose just to write some text in a different location by turning off the Smart Sketching, turning off and just selecting the text. This would allow us to write house and now draw an arrow to where we want it to be. For instance, pointing it to the house. This is very helpful if you have images you want to collect in the field, but you want your users to be able to annotate them at the time they draw them. You can also set a default background as we described. For instance, here we have a picture of a turtle. This has been set as the default background, and now we can annotate on top of that. For instance, if we need to highlight something on this image, we can simply select it and draw a circle where the highlighted area is needed. Similarly, we can also now use this select question to control the default. So for instance, if I select coyote, open this, I will now get a picture of a coyote. If I go back and select turtle, I will now see the picture of the turtle. And if we wanted to, we could now change this to use a map. So I can select the map, it will show my location, and now I can insert that and annotate using the Smart Sketching tools on top of it. For instance, I may want to draw a green line around one of the parks that we can see nearby. So here I can draw around this park and give it a label. So these are some very easy ways you can use image and draw appearances to annotate your questions in Survey123. And finally now, we'll look at using pool data at EXIF to extract metadata from an image. Photos or images taken with modern day cameras contain EXIF metadata. This metadata generally includes the date, location, device details, and can contain many more metadata information. Currently there are over 200 known tags. In Survey123, when an image is taken, metadata is stored following the EXIF standard. You can use the metadata at EXIF function to extract this information from the image. Remember, if you want the location and other location-based information in your image, make sure the GPS icon has stopped flashing and has a valid location before taking your photo. Here is an example of how pool data at EXIF can be used to return the latitude, longitude, and altitude of the image selected in the image question type labeled photo. If you want to learn more about extracting data from EXIF images with Survey123, please refer to the Survey123 online documentation or check out this great blog post available in the Survey123 GNet site. Let's take a look at how we can configure Survey123 Connect to use pool data at EXIF and how it works in the Field app. Over in Connect, we now have a pool data at EXIF survey in our gallery. Let's take a look and see how the XLSForm has been set up. We have an image question. With this image question, we have set up some relevant questions following it so that once the image question has been taken, it will be displayed. Here we can see how this was done. The image question will simply take the photo. However, following this, based on the image being existing, you will be able to use these following calculations with string at pool data EXIF image tag. This allows the information to come through from the EXIF data, and we can use it to pull out the GPS latitude, longitude, and latitude. I have downloaded the survey in the Field app, so let's take a picture. Now we'll simply take a photo. As mentioned before, we need to make sure we have a GPS signal and this is not flashing so that we can record that information into the metadata. Now I will take the photo, and here we can have a look and see what EXIF information we can pull from the photo. By default, we have pulled the latitude and longitude, and as I'm using a GPS on my desktop, I do not have an altitude. However, here we can use this select one to look at all the types that are available. As you can see, there are many different metadata types available that any type of image can contain. So let's just have a look for some that we could use. Image date time is a good example of one useful property. Image software, and other properties such as GPS map datum. As you can see, this is very useful information that you can pull out of your photo and you can include in your survey. In summary, in this presentation we've covered a wide variety of advanced XLSForm techniques to help you get the most out of using Survey123 and to help you maximize productivity, streamline workflows, and ensure you are capturing data in the easiest possible way. We hope that you have found this presentation and the demonstrations useful, and it has provided you with some ideas about how you can use advanced XLSForm techniques to improve your workflows and data capture using Survey123. If you have any questions, comments or feedback, please talk to your account manager, Esri support, or use the Survey123 GNet forum to ask questions and learn what other users are doing with their Survey123 forms. Once again, thank you for your attention throughout this presentation.